you can follow the following transforming order to figure out this graph. This is the given function. It is a transformed function. Observe its expression. You can figure out its parent function should be y equals sine theta. Here, we use theta to represent this pi. That to say, this is the original function, or we can say it is the parent function. Here, theta is the independent variable, y should be dependent variable. The corresponding point on this graph should be theta, y. Then we need to observe for this transformed function, then compare this specific expression with the standard form of the transformed function. You can find out here it is a, so a equals 4. This one, 3 equals k equals 3. D is 60 degrees, so d equals 60 degrees. Here plus c, but here it is minus 1, so c equals -1. You need to transform this parent function according to the correct transforming order. That is, you need to transform this basic function according to these two parameters first. After this, you need to transform the function according to these two parameters. That is, the transformations according to these two parameters must be performed before the transformations according to these two parameters. All right? We have known here it is the theta. So we can figure out this relation. That is, theta is replaced with this pi, so theta equals k times x minus d. So if we solve this expression, we will figure out x equals theta divided by k, then plus d. Okay, this x is this x. That is, this x equals this one. So the point on this transform function, its coordinate should be x, y. But this x equals this one, so we use this expression to replace x coordinate. This is the x coordinate. The y coordinate should be this a times y plus c. Here, a is this parameter. This y is this one. That is, we can figure out its value. Then we need to use a to multiply this y coordinate. On the basis of a times y, we need to add c, so plus c. Here, we use a times y plus c to represent the y coordinate. Okay, now here k is 3, so we use 3 to replace k. D is positive 60 degrees, so we use 60 degrees to replace D. Y is y. A is 4 plus c. C is -1, so we use -1 to replace plus c. That is, this point should be the point on this transformed function. Here you know theta is this theta, y is this y, but on the original function, the point should be represented by these coordinates, theta, y. On the transformed function, every point, its coordinate should be represented by this x coordinate and y coordinate. All right. So for this original function, you know over one period, this is one period. We can figure out one cycle, but you know for sinusoidal function, we can extend this function, this graph, in two directions continuously. Okay. For this one period, we can figure out the 5 critical points. That is, 3 zeros, 1 highest point, 1 lowest point. So they are 5 critical points. the corresponding y-coordinate should be 0, 1, 0, -1, 0. So we can figure out the corresponding coordinates for every point that you say 0 degree, 1. This is the point that you say the origin. This coordinate should be related to this point that you say 90 degrees, 1. This point, its coordinate should be this one. This point, its coordinate should be this one. This point, its coordinate should be 360 degrees, 0. For every point, we can make use of the expression to transform the original critical point to the corresponding image point. But the image point, they are on the graph of the transformed function. For this point, you know 0 degree should be theta. 0 should be y-coordinate. Then you can use 0 degree to replace theta. This 0 should be used to replace y. According to these two expressions, you can figure out this x-coordinate and this y-coordinate. That you say here it is 0 degree divided by 3 plus 60 degrees. So it will be 60 degrees. 60 degrees. Here y should be this 0. So 4 times 0 minus 1, it will be -1. -1. Okay? So point A should be 0 degrees, -1. We can locate this point A in the same Cartesian plane. It will be here. For every critical point, we can make use of these two expressions to figure out the corresponding x-coordinate and the y-coordinate on the transformed function. So we can figure out this point, its image point should be this one. Point B, it will be here. This origin point, its image point should be 120 degrees, -1. It will be this point C. Similarly, we can figure out point D, it is here. We can figure out point E, it is here. Then you can connect the 5 critical points one by one. Then you will get the graph over one period for the transformed function. You know, here its x-coordinate is this one. This point, its x-coordinate should be this 180 degrees. The distance between these 2 points should be 120 degrees. This one should be one period. According to this transformed function, we know k is 3, so the period should be this over 3. 3 should be k. So the period should be 120 degrees. So this is just the one period. Over this one period, we will get the corresponding graph. We say this is one cycle. Of course, you can extend this graph in 2 directions. That is, we can figure out the graph for this transformed function. That is the given transformed function. Here, the yellow graph should be the graph of the original or parent function. That is y equals sine theta. They are sinusoidal functions. This function is the transformed function of the original function.